Welcome to Certified Data Engineer Associate DEA-C01 Practice Exam number 14. You'll get 30 exam-style questions. I will read each question, then give you a 10-second countdown to review the answer choices on screen. Feel free to pause the video if you need longer. After each countdown, I will reveal the correct answer and explanation. Question 1. Tailspin Logistics stores shipment tracking data in Amazon DynamoDB. The table uses shipment ID as the partition key and timestamp as the sort key. Each item includes a TTL attribute set to expire records after 90 days. The operations team reports that expired items are still appearing in query results for several hours after their TTL timestamp passes. What explains this behavior and what should the data engineer recommend? Select 1. Review the answer choices on screen. The correct answer is option A. DynamoDB TTL deletions are performed as background processes and can take up to 48 hours after the expiry timestamp to physically remove items. During this period, expired items remain in the table and can appear in red operations, including queries and scans. The recommended approach is to add a filter expression in the application to exclude items where the TTL attribute is less than the current time. The TTL attribute must be a number type containing an epoch timestamp, not a string type. DynamoDB streams is not required for TTL deletions to occur, though TTL deletions can optionally generate stream records. TTL is a continuous background process, not tied to maintenance windows. Question 2. A company uses Amazon Redshift with key distribution and experiences one node consuming significantly more CPU than others during business hours. Budget constraints prevent adding nodes. Which adjustment balances the workload distribution? Select one answer. Review the answer choices on screen. The correct answer is option B. The uneven CPU distribution across nodes indicates that the current distribution key has low cardinality or produces data skew, concentrating rows for certain key values onto one node while other nodes receive fewer rows. Changing the largest dimension table's distribution style to even redistributes rows in a round-robin fashion across all nodes regardless of key values, eliminating the concentration that causes one node to perform disproportionately more work. This resolves the load imbalance without changing the node count or size. Scaling up a single node is not possible in Amazon Redshift because all nodes in a cluster must be of the same type. The cluster is scaled by changing the node type or count, not individual nodes. Changing the primary key affects how data is uniquely identified in the table, but does not influence data distribution across nodes unless the distribution key is explicitly changed to that column. Sort keys control how rows are physically ordered within each node's storage to optimize range-restricted queries. They do not affect data distribution across nodes and would not address the uneven CPU utilization. Question 3. A company's ETL pipeline uses AWS Glue to load data from S3 into Redshift using the truncate command before inserting new data. Jobs are getting stuck due to an access share lock on the table. Which two steps resolve this problem? Select 2. Review the answer choices on screen. The correct answers are option A and option B. The Redshift truncate command requires an access exclusive lock, which blocks when another session holds an access share lock. To resolve this, the first step is to identify which session is holding the conflicting lock by querying the system views such as SDV, LOCKS, and SDL sessions to find the process ID responsible. Once identified, PG terminate backend terminates that specific session, releasing its locks and allowing the truncate to proceed. Together, these two steps diagnose and resolve the blocking condition. The vacuum command reclaims disk space and resorts rows, but has no effect on active lock states held by other sessions. Explain analyzes query execution plans to improve future performance, but cannot release currently held locks or unblock a waiting transaction. REINDEX rebuilds table indexes to restore query efficiency after significant data changes, and similarly has no ability to release or clear active session locks. Question 4. A data engineer at Contoso Energy stores time series sensor data in Amazon TimeStream. The data includes temperature readings from 10,000 sensors collected every minute. Queries on recent data, last 24 hours, must return within 2 seconds, while historical queries spanning 6 months are run weekly for trend analysis. The data engineer needs to optimize storage costs while maintaining query performance. Which TimeStream configuration should be used? Select one. Review the answer choices on screen. The correct answer is option D. Setting memory store retention to 24 hours keeps recent data in high-performance memory storage for sub-second queries, while 6-month magnetic store retention provides cost-effective storage for historical trend analysis. Enabling magnetic store writes ensures late-arriving sensor data that falls outside the memory store retention window is not rejected. TimeStream automatically moves data from memory to magnetic store based on the retention policy. Setting memory store to 7 days stores more data than needed in the expensive memory tier, increasing costs without performance benefit since only 24-hour queries need fast response. Storing all data in memory for 6 months would be extremely expensive for 10,000 sensors at 1-minute intervals. Setting memory store to only 1 hour risks missing some recent data needed for the 24-hour query requirement, especially during delayed processing. Question 5. A marketing agency stores daily sales campaign results in an S3 data lake. Analysts need to visually verify data quality against set standards before transformation. Which solution fulfills this requirement with the least management overhead? Select one answer. Review the answer choices on screen. The correct answer is option A. AWS Glue Data Brew is a serverless visual data preparation tool that connects directly to S3 datasets without requiring infrastructure provisioning. Profile jobs automatically compute data quality metrics including completeness, uniqueness, and distribution statistics, and display results on a dashboard. Custom rule sets can be defined to validate specific business requirements and flag violations visually, exactly matching the requirement for analysts to verify data quality before transformation. Running an EMR cluster requires provisioning, scaling, and ongoing maintenance. Spark mlib adds ML complexity that is unnecessary for straightforward data quality checks. Streaming existing S3 data through Kinesis Data Firehose to OpenSearch introduces unnecessary data movement and infrastructure for a batch data quality verification use case. Deek requires writing Scala or Python code to define constraints and does not provide a visual interface for analysts to review quality results. Question 6. Northwind Corp operates an Amazon MWAA environment running Apache Airflow for their data pipeline orchestration. A data engineer notices that newly uploaded DAG files take several minutes to appear in the Airflow UI, and the team wants to add a custom Python library that is not available through PyPy. Which 2 actions should the data engineer take to address these requirements? Select 2. Review the answer choices on screen. The correct answers are option A and option C. MWAA supports custom libraries through the plugin zip mechanism, where custom Python packages and operator plugins are uploaded to the S3 plugins folder configured for the environment. The DAG synchronization delay of approximately 300 seconds for new DAGs is expected behavior for MWAA, as DAG files are synced from S3 to the Airflow scheduler periodically. SSH access to MWAA worker nodes is not available since it is a fully managed service. MWAA does not support EFS volumes for DAG storage. DAGs must be stored in S3. Modifying internal scheduler intervals is not supported in the managed MWAA service. Question 7. Tailspin Corp has a real-time application that produces 500 MB/s of clickstream data. The data must be processed with exactly once semantics, windowed aggregations every 5 minutes, and late-arriving events must be handled gracefully using watermarks. Which architecture should the data engineer implement? Select 1. Review the answer choices on screen. The correct answer is option B. Amazon Managed Service for Apache Flink, formerly Kinesis Data Analytics, provides exactly once processing semantics via checkpointing, supports event-time windowing with watermarks for late data handling, and can process high-throughput streams from Kinesis data streams. Flink's watermark mechanism specifically addresses late-arriving events by tracking event time progress and routing late data to side outputs. Amazon Data Firehose does not support exactly once semantics, custom windowed aggregations, or watermarks. It is a delivery service, not a processing engine. KCL consumer applications provide at least once semantics and would require custom implementation for windowing and watermarks. Lambda tumbling windows are limited to 15-minute maximum function duration and do not support watermarks or exactly once processing across windows. Question 8. Contoso Media ingests clickstream data through Amazon Data Firehose to Amazon S3. The team wants to dynamically partition the data by user country and event type fields extracted from each JSON record. After enabling dynamic partitioning, the team notices that the buffer interval cannot be set below 60 seconds. They need the lowest possible delivery latency. What should the data engineer understand about this limitation? Select 1. Review the answer choices on screen. The correct answer is option B. When dynamic partitioning is enabled in Amazon Data Firehose, the minimum buffer interval is 60 seconds, and the buffer size range is restricted to 64-128 MB. This is a hard limitation that cannot be circumvented. 0-second buffering, 0 seconds, is only available for S3 destinations when dynamic partitioning is not enabled. Setting the buffer size to 64 MB does not override the minimum interval requirement. Moving partition key extraction to Lambda does not change the dynamic partitioning buffer constraints because the partitioning behavior is what imposes the minimum interval, regardless of how partition keys are extracted. If lower latency is absolutely required, the team would need to consider alternative architectures such as Kinesis data streams with a custom consumer application. Question 9. Fabricam Energy has an AWS step functions workflow that orchestrates a nightly data pipeline. The workflow runs a glue crawler, waits for completion, then triggers a glue ETL job, and finally runs an Athena query to validate the output. The ETL job occasionally fails due to transient network errors when connecting to a JDBC source. The data engineer wants to add automatic retry logic specifically for the glue ETL job step without restarting the entire workflow. Which step functions configuration should the data engineer implement? Select 1. Review the answer choices on screen. The correct answer is option A. Step functions provides built-in retry functionality at the individual task state level. By adding a retry field to the glue ETL task state with appropriate error equals, interval seconds, max attempts, and backoff rate parameters, the workflow automatically retries only the failed step without restarting earlier steps. This is the native and recommended approach for handling transient failures. Using a parallel state creates unnecessary complexity and does not provide true retry logic. A choice state looping back would work, but is more complex and harder to maintain than the built-in retry mechanism. While glue jobs do have a max retry setting, relying on step functions retry provides better visibility, configurable backoff, and integration with the overall workflow error handling, including catch fallback states. Question 10. A company uses an AWS Glue ETL pipeline to crawl a Microsoft SQL Server table, transform the data, and load it to an Amazon S3 bucket. The data engineer must also orchestrate this pipeline. Which AWS service meets these requirements most cost-effectively? Select one answer. Review the answer choices on screen. The correct answer is option D. AWS Glue workflows are designed specifically to orchestrate sequences of AWS Glue crawlers and ETL jobs. A workflow can trigger a crawler to catalog the SQL Server table, wait for completion, and then trigger the ETL job that transforms and loads data to S3, all within the same Glue service at no additional orchestration cost beyond the standard Glue job execution charges. Because workflows are a native Glue feature, there is no separate service to provision or pay for. AWS Step Functions is a general-purpose serverless workflow orchestration service that can invoke Glue jobs and crawlers, but charges per state transition, adding incremental cost for a task that Glue workflows handle natively without additional charges. Glue Studio is a visual ETL job authoring interface for designing and running individual Glue jobs. It does not provide workflow orchestration capabilities for sequencing crawlers and jobs. Amazon MWAA deploys a managed Apache Airflow environment with dedicated compute resources and continuous costs, which is significantly more expensive than a native Glue workflow for a straightforward crawler than ETL sequence. Question 11. Fabricam Insurance has an AWS Glue ETL job that reads from a JDBC source PostgreSQL containing 500 million records. The job takes over 6 hours to complete due to a single JDBC connection reading data sequentially. The table has an auto-incrementing integer column called record id. Which optimization reduces the job execution time most effectively? Select one. Review the answer choices on screen. The correct answer is option D. Configuring JDBC partitioning with num partitions, lower bound and upper bound on the record id column enables Spark to open multiple parallel connections to the PostgreSQL database, each reading a different range of record id values. This is the standard Spark JDBC optimization that directly addresses the sequential single connection bottleneck. Job bookmarks prevent reprocessing but do not speed up the initial full read, and larger workers help with processing but not with the JDBC read bottleneck. Glue pushdown predicates with hash-filled partitioning is a valid approach for S3-based partition pruning, but does not apply to JDBC sources in the same way. Migrating data through DMS adds an entirely separate migration step and significant complexity when the goal is simply to optimize the existing Glue job's JDBC read performance. Question 12. Litware Analytics uses Amazon Athena to run daily reports against Parquet files stored in Amazon S3. The data is partitioned by year, month, and day in Hive-style format. Year equals YYYY/month equals MM/day equals DD, with new partitions added every day. The team currently runs MSCK repair table each morning before generating reports, but this operation takes over 40 minutes due to millions of existing partitions and is delaying the reporting pipeline. The team wants to eliminate the partition discovery bottleneck and minimize ongoing operational overhead for Athena queries. All analytical queries are performed exclusively through Athena. What should the team do? Select one. Review the answer choices on screen. The correct answer is option D. Partition projection eliminates the partition discovery bottleneck entirely by computing partition values and locations in memory at query time based on rules defined in the table properties. For date partition data with a predictable year/month/day pattern, Athena calculates which partitions to read without making any getPartitions API calls to the Glue data catalog. This removes the 40-minute MSCK repair table operation completely and requires zero ongoing maintenance as new daily partitions are automatically projected. Using Lambda with batch create partition registers partitions in the Glue data catalog with low latency, but still requires maintaining infrastructure and incurs get partitions lookup costs at query time against millions of partitions. A Glue crawler with crawl event mode detects new partitions faster than scheduled crawling, but adds crawler startup overhead and still relies on catalog lookups during queries. Partition indexes improve catalog lookup performance, but do not eliminate the fundamental bottleneck of scanning millions of partition entries. An MSCK repair table would still need to run for new partition discovery. Question 13. Fabricam Analytics has an AWS Glue ETL job with job bookmarks enabled that processes JDBC data from an Amazon RDS PostgreSQL database. The job uses a timestamp column called last modified as the bookmark key. After a recent database maintenance window, some rows were updated with timestamps older than the current bookmark checkpoint. These rows are not being picked up by subsequent job runs. What should the data engineer do? Select 1. Review the answer choices on screen. The correct answer is option A. The pause bookmark state allows processing incremental data within a specific range defined by job bookmark from and job bookmark to parameters without updating the bookmark state. This enables the engineer to reprocess the specific time range where rows were updated with older timestamps. After the targeted reprocessing completes, the bookmark can be returned to enabled state to resume normal incremental processing. Switching to the primary key would miss rows that were updated in place without changing the primary key. Disabling bookmarks and implementing custom logic adds unnecessary operational complexity. Glue job bookmarks for JDBC sources support only one or more columns as a compound bookmark key, and adding secondary keys does not solve the fundamental issue of rows updated with older timestamps. Question 14. Litware Inc. has an Amazon Redshift cluster with a 1 TB sales transactions fact table that is frequently joined with a 30 MB product categories dimension table and a 500 GB customer orders table. Analysts report that joins between the sales transactions table and the customer orders table on the customer ID column are causing significant query latency. The product categories dimension table is referenced in nearly every analytical query across all compute nodes. Which combination of distribution and sort key strategies should the data engineer implement to optimize query performance? Select 2. Review the answer choices on screen. The correct answers are option A and option C. For optimal join performance between the sales transactions fact table and the customer orders table, both tables should use key distribution on the customer ID join column. When two tables share the same distribution key on a join column, Redshift collocates matching rows on the same node slices, eliminating costly data redistribution during joins. The 30 MB product categories dimension table should use all distribution because it is a small, slowly changing table referenced across all compute nodes. All distribution places a complete copy on every node, eliminating redistribution costs for joins with this table. Applying even distribution on the fact table would scatter rows randomly across slices, requiring data redistribution for every join on customer ID. Applying all distribution on the 500 GB customer orders table would replicate the entire table to every node, massively increasing storage requirements and dramatically slowing data loads. Relying on auto distribution for the fact table may not select the optimal customer ID distribution key, since Redshift may choose a different column or default to even distribution. Question 15. Northwind Retail operates a data lake on Amazon S3 with hundreds of databases and thousands of tables registered in AWS Lake Formation. The company is onboarding 15 new analytics teams, each requiring access to different subsets of data based on their business domain. The data governance team wants to minimize the number of individual permission grants and simplify ongoing access management as new tables are added. Which approach should the data engineer recommend? Select 1. Review the answer choices on screen. correct answer is option B. Lake Formation Tag-Based Access Control, LFTBAC, using LFTAGs is the recommended approach for large-scale data lakes. LFTAGs are key-value pairs assigned to databases, tables, and columns, and permissions are granted based on tag expressions. This scales linearly rather than exponentially, with the named resource method. Granting access to n principals on m resources requires n times m grants, while LFTBAC requires only n plus m operations. When new tables are added and inherit tags from their parent database, existing team permissions automatically apply without additional grants. Creating IAM policies with individual ARNs is operationally complex and doesn't scale. Separate S3 buckets fragment the data lake architecture. The named resource method requires individual grants for each team table combination, creating significant administrative overhead. Question 16. A data engineer at Litware Pharma needs to query data across both a Redshift serverless workgroup and an Amazon Aurora PostgreSQL database. Analysts want to join Redshift warehouse tables with live Aurora transactional data in a single SQL query without moving data. Which Redshift feature enables this? Select one. Review the answer choices on screen. The correct answer is option D. Redshift federated queries allow querying live data in Amazon Aurora PostgreSQL and MySQL and RDS PostgreSQL directly from Redshift using external schemas. This enables joining Redshift warehouse tables with transactional Aurora data in a single SQL query without ETL. Redshift Spectrum is designed to query data stored in Amazon S3, not relational databases like Aurora. Data sharing is for sharing data between Redshift clusters and workgroups, not for connecting to Aurora databases. The copy command loads data into Redshift tables from sources like S3, not for live querying of external databases. Question 17. Tailspin Energy operates an Amazon OpenSearch service domain for analyzing IoT sensor logs from wind turbines. The domain stores 90 days of data, but analysts only actively query the most recent 7 days. Storage costs are increasing rapidly. The data must remain queryable for the full 90 days for compliance investigations. Which approach should the data engineer implement to reduce storage costs while maintaining query access? Select one. Review the answer choices on screen. The correct answer is option C. OpenSearch Index State Management (ISM) policies automate the lifecycle of indices across storage tiers. UltraWarm provides S3-backed, read-only storage at significantly lower cost than hot storage, ideal for data that is infrequently queried but must remain accessible. Cold storage further reduces costs for data that is rarely accessed. Cold indices must be reattached to UltraWarm before querying, but this still meets the compliance requirement of remaining queryable. Exporting to S3 snapshots and using Athena would work, but requires leaving the OpenSearch domain entirely for compliance queries, adding operational complexity, and losing the OpenSearch query capabilities that analysts are familiar with. Adding more data nodes increases cost rather than reducing it. Removing all replicas eliminates high availability protection against node failures and risks data loss, which is unacceptable for compliance data. Question 18. Fabricam Retail has an Amazon SQS FIFO queue receiving order processing messages. During peak sales events, the queue experiences throughput bottlenecks at 300 transactions per second. The data engineer needs to increase throughput while maintaining strict ordering within each customer's orders. Orders from different customers can be processed independently. Which solution should the data engineer implement? Select one. Review the answer choices on screen. The correct answer is option D. Enabling high throughput mode on an SQS FIFO queue increases the throughput limit to up to 30,000 messages per second with batching. Using customer ID as the message group ID ensures that orders from the same customer are processed in strict FIFO order, while orders from different customers can be processed in parallel across different message groups. Switching to a standard queue would provide unlimited throughput, but loses exactly once processing and strict ordering guarantees, which are required for order processing. Creating multiple FIFO queues adds significant application complexity for routing and does not natively maintain per customer ordering guarantees across queues. Increasing visibility timeout does not address the throughput bottleneck and only affects how long messages are hidden from other consumers after being received. Question 19. A company deploys containerized data transformation workloads on Amazon EKS running on EC01 nodes. Each container processes a distinct dataset and stores results in a data lake. Data sharing between containers is prohibited. Which storage solution provides the lowest latency for temporary dataset access? Select one answer. Review the answer choices on screen. The correct answer is option A. An ephemeral volume backed by the EC01 node's RAM provides direct in-memory storage access within the same physical machine, eliminating all network round trips. Since the requirement explicitly prohibits data sharing between containers and focuses on lowest latency, local ephemeral storage from node RAM is the optimal choice, offering sub-microsecond access times comparable to processor cache. EFS-backed persistent volumes require network I/O to reach the managed file system over the network, adding latency that exceeds local storage options, even though EFS provides excellent scalability. MemoryDB for RDS is an external in-memory database that requires network calls to reach the service endpoint, introducing latency that local node RAM avoids. DynamoDB Accelerator is an in-memory cache for DynamoDB that also requires network connectivity, making it inherently slower than local ephemeral storage for temporary working data. Question 20. Tailspin Analytics is building a data pipeline that orchestrates an AWS Glue crawler followed by a Glue ETL job, then loads the results into Amazon Redshift. The pipeline must also handle an EMR Spark job for a separate data enrichment step that runs in parallel with the Glue ETL job. Both outputs must be verified before the Redshift load begins. Which orchestration service should the data engineer use? Select one. Review the answer choices on screen. The correct answer is option C. AWS Step Functions provides native integration with both AWS Glue and Amazon EMR through the Run a Job Sync pattern, which waits for completion before proceeding. Step Functions supports parallel state types that can run the Glue ETL job and EMR Spark job concurrently and wait for both to complete before triggering the Redshift load. This matches the requirement for parallel execution with synchronization. Glue workflows can orchestrate Glue crawlers and jobs natively, but do not support EMR job steps as part of the workflow. MWAA would work, but introduces significant operational overhead for managing Airflow infrastructure, including VPC, NAT gateway, and DAG management. Event bridge rules are event-driven and do not natively support parallel execution with synchronization or waiting for job completion. That is the end of practice exam number 14. Review the questions you missed, then come back for the next batch.